Okay, so we will discuss today about the basic counting as well as advanced counting concepts. So our topic for the day is counting. Okay, so I'll just go through the fundamentals of counting. You all must be knowing or heard about the terms of NCR and NPR. So it is basically selecting R items from N items can be done in NCR ways on arranging R items from N items can be done in NPR ways. Okay, so the formulas we can use for this are NPR is equal to N factorial divided by N minus R factorial, and NCR is given by N factorial divided by N minus R factorial into R factorial. Okay, so these two fundamental equations we will be utilizing in solving all the problems based on counting. We will first discuss some elementary problems from counting, and then we move on to some advanced problems on counting. Okay, so we'll start off with some simple problems. In how many ways can you seat five people in a row of three chairs? So we can do this particular problem based on our fundamental logic as well as using the formulas of combination and permutation, right? So let us see, three chairs are there, which means we have three positions for seating five people, right? In the first position we can actually seat any of the five persons, which means you can do it in five different possibilities. Once the first position is filled, you have the second position which can be filled in four different ways, right? And the last position can be filled in three different ways. So naturally, from the fundamental principle of counting, we can do this uh, arrangement in 5 into 4 into 3, which is equal to 60 different ways. Okay. Now, using the formula, let us select first three people from five people, which can be done in 5C3 ways. And these three people can be arranged among themselves in 3 factorial different ways, right? So that is 5 factorial divided by 5 minus 3 factorial, okay, into 3 factorial into 3 factorial, okay. So we can cancel out these 3 factorials. So it becomes 5 factorial divided by 2 factorial. So that is equal to 5 into 4 into 3 again, which is equal to 60. Now using the permutation formula, you can directly do it because we are arranging 3 people from 5 people. So that is 5p3 itself, which is equal to 5 factorial divided by 5 minus 3 factorial, which will also give the same result, which is 60. Okay. Now, how many ways to arrange the letters of the word banana? See, there are 6 letters, out of which B is not repeated. B happens only once. A happens 3 times, and N happens 2 times, right? So B can take any of these positions, which means you can do it in 6C1 different ways, right? And A can take remaining 5 positions in 3 different ways. So you can do it in 5C3 ways, right? And the last 2 letters are N, which can take 2 out of 2 positions, because once B and 3A's are over, you have only 2 positions left out, which have only 2 different ways to fill. So this will give the answer, which will be 6C1 is 6, and 5C3 is actually 5 into 4 divided by 1 into 2, right? And 2C2 is actually 1, which means you will have, this is 2. So 6 into 5 into 2, that is 60 into 5 is 30. 30 into 2 is 60 different ways. Okay. Now you can do it in another way also, which is if you have say n items which can be arranged, and out of which r1 comma r2 are the number of repeated items, then you can do it as n factorial divided by r1 factorial into r2 factorial, right? Here we have n given by 6, and r1, r2 and r3 are there. There are three different items. R1 happens only once, R2 happens three times, and R3 happens two times, right? Here R1 represents B, R2 represents A, and R3 represents N. So what will be the answer according to this formula? It will be 6 factorial divided by 1 factorial into 3 factorial into 2 factorial, right? So that is equal to 6 into 5 into 4 into 3 factorial divided by 3 factorial into 2 factorial, right? So 3 factorial and 3 factorial cancels out. 2 factorial is 2, which means you can cancel out this with 2. So 6 into 5 into 2, again the answer turns out to be 60. Okay. Problem is how many binary strings can be formed from 5 ones and 3 zeros. So we have here 5 ones, okay, and 3 zeros. So just like our previous problem, we have total of 8 items here, right? And 5 of them is repeated ones and 3 of them are repeated zeros. So using our previous logic, we can do it as 8 factorial divided by 5 factorial into 3 factorial, right? Which is equal to 8 into 7 into 6 into 5 factorial divided by 5 factorial into 3 factorial, right? So 3 factorial is 6. So you can cancel out 5 factorial, and 3 factorial and 6. So 8 into 7, answer is 56. See, also we can do it in another way, which is we have a total of 8 bits here. And out of these 8 bits, we can select 5 bits in 8C5 different ways, right? And remaining 3 bits are zeros, which can be selected in only one way, right? So that is 1. So your answer will be actually 8 factorial divided by 5 factorial, which is equal to, sorry, 8 factorial divided by 8 minus 5 factorial into 5 factorial, right? Which will again give you 56 as the answer. Okay, given the alphabet A, B, C, D, E, how many different three-letter words can be generated if repetitions are allowed? See, in this particular problem, they are asking three-letter words. Okay, so we have three different positions to fill, and they have told that repetitions are allowed, which means I can put A, B, C, D, or E in any of these positions, which means I can put 5 different combinations here, or 5 different combinations here, again 5 different combinations here. So the answer for this particular problem is 5 into 5 into 5, which means 5 cube. So that is equal to 125. Enumerate the number of ways of placing 20 indistinguishable balls into 5 boxes. So this is a particular problem which can be done in a lot of different ways, and this is a base problem for dealing with a certain set of problems. Okay, so we will discuss this one in detail. Let us assume there are 5 boxes. Okay, so we have 1, 2, 3, 4 and 5 boxes. Now 20 indistinguishable balls are there, which means I can assume there are 20 balls. Okay, so let us say 1 to 20 balls are there, they are indistinguishable. How many different ways can you distribute these balls into 5 boxes such that a box can even be empty also? So I can put 20 balls into first box and or other box empty. That is also a possibility, right? Now we can just think about all these balls as zeros. Let us assume all these balls are zeros. Okay. Now I will do the separation of each ball into a particular box by marking a 1. For example, I will consider a simple problem to make it easy to understand. For example, suppose I have 4 balls, okay, and I want to put it into two different boxes, so I can put the separation here, which means in one box there will not be any ball, and in the other box there will be 4 balls. I can put the separation after 1 0, which means 0 1 0 0 0. Let us assume all the zeros are balls. Okay, so here one box have one ball, other box have 3 balls, right? Similarly, I can put the one after 2 balls, right? Which means I will have, let us say, 2 balls in the first box and 2 balls in the second box. Now, this is now the similar to a problem of binary string, right? Which means I will have 1 2 3 4 and 5 elements in the string, right? 5 elements in the string, and 4 of them are repeated, right? Which means how many different ways can I do the separation? Can I do the arrangement of the strings? 5 factorial divided by 4 factorial, right? Similarly, I can do here also. Here there are 5 boxes, which means there will be how many ones there will be when you consider 5 boxes, there will be 4 separations, because when you have 2 boxes, there is only one separation is enough, right? When there are 3 boxes, you need to have 2 separations. Similarly, when you have 5 boxes, there will be 4 ones. Okay, and all the balls I can consider as zeros, which means 20 zeros will be there and 4 ones will be there, right? So there will be total of 24 elements. So 24 factorial divided by 4 factorial into 20 factorial will be the answer to this particular problem. Okay. The same problem, actually, I can think of doing in another way. That is the selection way of doing the same problem. See, we have 20 different balls, right? Which means we have a string of, let us say, 20 zeros, and there will be 5 boxes, means we need to make 4 separations, right? There will be 4 ones in between these 20 balls, anywhere in between, right? Now, if you consider there are n balls and r boxes, what will be the total number of elements in the string? Here it is 20 plus 5 minus 1, correct? Why? Because when there are 4 boxes, you need only 4 separate. I mean, 5 boxes, you need only 4 separations. That is why this 5 minus 1 has come. So there will be n plus r minus 1 elements in the string if you put it as a binary string, right? And out of which you can select either r minus 1 once, or that is also equal to the basic theory of combination tells you n plus r minus 1 c, sorry, minus 1 c n, correct? Out of which, see, there will be n plus r minus 1 elements. From these elements you can either choose r minus 1 once, or that is equivalent to choosing n zeros. So in this particular problem, you can put n is equal to 20, r is equal to 5. Hence I can write the answer for this question as 20 plus 5 minus 1 c 5 minus 1, or that is also equal to 20 plus 5 minus 1 c 20, right? So that is equal to 20 plus 5 is 25, 25 minus 1 is 24 c4, or that is also equal to 24 c20. Now the same problem, let us reframe in another way, or an equation based way of asking the same question. Let us consider all the boxes being given names. Okay, there are 5 boxes. I am giving the names h1, h2, h3, h4, and h5 as the number of balls in each boxes. So finally, I can frame an equation like h1 is the number of balls in the first box. So h1 plus h2 is the number of balls in the second box, plus h3 plus h4 plus h5 will give me total bolts, right, is equal to 20, correct? So I can write this as h1 is the number of bolts in the first box, h2 is the number of bolts in the second box. So I can always write h1 plus h2 plus h3 plus h4 plus h5 is equal to 20, right? Now this is an equation which can be asked in a different way, right? Non-negative integral solutions for this equation, which means the idea of that question is you can have only values for x1, x2, etc. greater than or equal to 0. That is the meaning of non-negative integral solution for this equation, right? Now the solution of this problem is similar to the one which we have done earlier also. That is, you have 20 different balls and 5 different boxes. So you can apply the principle n plus r minus 1 c r minus 1. Okay. In any of the questions which are framed in this particular manner, you can apply the simple counting principle which we have done with this particular problem, that is 20 indistinguishable balls into 5 boxes. We have done it in 3 different ways now. The same principle you can apply in this particular class of questions also. Enumerate the number of ways of placing 20 indistinguishable balls into 5 boxes where each box is non-empty. Now this is a slight variation from the previous set of problems which we have done. The question is slightly changed. In the previous question, each box was supposed to be either empty or non-empty. But in this question, it is given the box has to be non-empty. Which means what will be the immediate change which you can think about is the 5 boxes are there. There should be at least one ball in every box. Correct? There should be at least one ball in every box. Now you think about these these one ball, that is 5 balls are distributed into each of the balls, right? Which means you will be left out with 15 balls now, right? And these 15 balls can be distributed into 5 boxes just as we have done in the previous problems. That is, from here onwards, your n is equal to 15, r is equal to 5, and you can apply the principle n plus r minus 1 c r minus 1 itself. The only thing you need to make sure is each box is non-empty. For that, I have first put a ball from the 20 balls. I am taking 5 balls from the 20 balls and distributing one into each box. So I have made the condition satisfied first. Then I am solving the problem just similar to the previous problem. That is the answer for this particular question. So here the answer will be 15 plus 5 minus 1 C4, right? Which is equal to, what is this, 20 minus 1 is 19. 19 C4 will be the answer to the question. So you think about this question as a slight modification from the initial question set which we have done, where 5 balls are taken from this 20 and are distributed into 5 boxes, one each, right? Which means whatever is left out will be 15 balls. Then we can do the problem similar to the basic idea. Okay. How many integral solutions are there to x1 plus h2 plus h3 plus h4 plus h5 equal to 20, where each xi is greater than or equal to 2? Now here you need to have all the boxes, minimum of 2 balls in all the boxes. So I am distributing 2 balls in each box first, okay, which means I will lose 10 balls for that purpose. So 20 minus 10, which is 10 balls will be left out to distribute in 5 boxes, similar to the empty or non-empty case, which means your n value is now 10, r value is now 5, and the problem solution is given by always n plus r minus 1 c minus 1. This formula you can use always. Only thing is you need to consider the initial condition. The initial condition given here is xi or xi greater than or equal to 2, which means I will distribute 10 balls as 2 balls each into each box. which means I will left out with 10 balls, and then I can apply the same old formula. Okay, so the answer will be 10 plus 5 minus 1, which is 14c4. Okay, so that will be the answer for this particular problem. The integral solutions are there to h1 plus h2 plus h3 plus h4 plus h5 equal to 20, where the conditions are given for the 5 boxes. So here also you can initially distribute the initial given condition, that is 3 volts is the minimum requirement in the first box, 2 is the minimum requirement in the second box, 4 is the minimum requirement in the third box, 6 is the minimum requirement in the fourth box, and you need not put any balls in the fifth ball. That can be empty also, which means I have 10 plus 2 plus 3, that is 15 balls already removed from this 20 balls, right? So whatever is left out is 5 balls. From that 5 balls I can apply the fundamental formula, which is 5 plus 5 minus 1 c 5 minus 1, which is equal to 9c4. That will be the answer. Many non-negative integral solutions are there to h1 plus h2 plus h3 plus h4 plus h5 less than or equal to 90. Now this is a variation from our initial set of problems. What we have seen so far is h1 plus h2 plus h3 plus h4 plus h5 equal to a fixed number. That is the class of problem we have done. So let us say this is equal to 19. Okay. Now we know the solution for this is what is that? 19 plus 5 minus 1 c4, right? Now if this is equal to 18, we have the solution 18 plus 5 minus 1 c4. Similarly, we can go until 0. So all these things you need to add up to solve this particular problem. That is one way of solving this problem. That is, we are splitting this problem into the class of problem we have already done, which is equal to a particular number. Now, since they have asked in the question it is less than 19, which means I can always put the value equal to 18, equal to 17, all combinations I need to take, right? This is one way of solving the problem, but there is even a better way to solve this problem or quickly solve it, okay? That is, let us assume h1 plus h2 plus h3 plus h4 plus h5 plus h6 equal to 90. Okay, now I know this is equal to less than or equal to 90, right? If this is equal to 19, then in the last box I need to put 0, right? If this is equal to 18, then in the last box I need to put 1. Now this is equal to the original class of or original fundamental class of problem we have already done, right? Which means adding one box to accommodate this less than number, so the additional number, we can solve this problem using the old formula, using a single formula, right? That is, we have n is equal to 19, r is equal to 6 here. So the problem solution will be n plus r minus 1 c r minus 1, that is equal to 24 c 5, right? N plus r is 19 plus 6 is 25, 25 minus 1 is 24, and 24 c5 will be the answer to this question. Suppose this question was framed in a different way, that is, instead of less than or equal to 19, I had the question given as h1 plus h2 plus h3 plus h4 plus h5 is less than 90. Okay, then I can put it in a different way. I can always write it as h1 plus etc. h5 is less than or equal to 80. Correct? That implies it is less than 19 also, which means then I can solve it as a new problem by adding a new box here. Example h1 plus etc. plus h5 plus h6 less equal to 18, where the additional number is I am adding another box. which means in that case the problem will be solved as n plus r minus 1 c r minus 1. That is the basic formula, but here n will be equal to 18 and r will be equal to 6. Hence the answer to the question will be 23c5. How many different outcomes are possible with 10 similar coins? So we have 10 similar coins and each coin can have an output of either head or tail. So the sum of head plus tail, number of heads plus number of tails, must be equal to 10. And the number here, head or tail, must be an integer which is greater than or equal to 0. Hence, this is a problem similar to our h1 plus h2 equal to 10. So you have n is equal to 10, r is equal to 2. So n plus r minus 1, c r minus 1 equal to 11, c1 equal to 11 is the answer. How many different outcomes are possible with 10 similar dice? We know each die can have 6 possibilities. So each possibility I am considering as a box. So you can consider 1, 2, 3, 4, 5, 6 boxes are there, and the number of ones, twos, threes, etc. sixes must add up to the total number of throws, right? Which is equal to 10. Now that is equivalent to h1 plus h2 plus etc. plus h6 equal to 10, where h1 represents the number of ones which came out, h2 represents the number of twos which came out, etc. out of 10 tosses. Now that is equivalent to n is equal to c 10, r is equal to 6, and hence the total number of possibilities is given by n plus r minus 1 c n, or n plus r minus 1 c r minus 1, which is equal to 15c5. How many integers between 1 and 1000 have sum of digits equal to 10? So we need to consider two different possibilities. Either it should be a 2-digit number or it should be a 3-digit number. Suppose we consider the 2-digit number case first. So let us assume h1 and h2 are the digits. Then h1 plus h2 must be equal to 10, where h1 and h2 are all positive single digit numbers. But we know h1 cannot be 0. Similarly, h2 cannot be 10. Also, h1 cannot be 10 and h2 cannot be 0. So these two possibilities we need to remove. So if we consider the combinations possible with this, it is directly n plus r minus 1 c n, which is equal to 10 plus 2 minus 1 c 10, which will give you 11c10, which is equal to 11, right? But we need to reduce the two combinations with our 0 10 and 10 0 possibility, because that cannot be taken here, which means the total number of cases we have will be 9 here. Now we will consider the case where 3-digit numbers are there. So h1 plus h2 plus h3 equal to 10. But h1 has to be greater than 0, because when you consider a 3-digit number, it cannot start with 0, which means I have the condition h1 greater than or equal to 1. So I can rearrange this equation as h1 plus h2 plus h3 equal to 9. Now I can apply this particular formula where n is equal to 9, r is equal to 3. So it will give us 9 plus 3 minus 1 c9, which is equal to 12 minus 1, which is 11 c9, which is also equal to 11 c2. It will be 11 into 10 divided by 1 into 2. So that will give me 55, right? So the total possible cases is 55 plus 9, which is equal to 64. Find the number of ways to put 4 black, 4 white, and 4 red balls in 6 different boxes. So we have 6 different boxes. So let us assume the boxes are h1, H2, H3 up to 6, H6. Okay, so the total number of bolts in the boxes must be equal to, let us assume first I am taking the 4 bolts, right? So I have to distribute the 4 bolts in 6 boxes, which I can do according to this particular formula, which is H1 plus H2 plus H3 plus H6 up to H6 equal to 4. So here I have n is equal to 4 and r is equal to 6, which means n plus r minus 1 c n will be equal to 10 minus 1 9 9 c 4, right? 9 c 4 will be equal to 9 into 8 into 7 into 6 divided by 1 into 2 into 3 into 4, right? So 2 into 4 I can cancel out 8, 3 goes here 2 times, so that will give me 63 into 2, so that will be 126, right? Now I can take next 4 white balls. Again here in this particular problem, since all balls are given to be 4, I can use the same formula. Otherwise you need to put that new number here. In this particular case I am taking 4 white balls, so again I'll get this particular number. So another possible combination is 126. See, all these are applying basic counting property. We should multiply these possibilities, because along with 4 black ball distribution I am going to do 4 white ball distribution, also I am going to do 4 red ball distribution. So all these final values I need to multiply to get the net result, right? Now when you take 4 red balls, again the same formula comes out. So final answer will be 126 into 126 into 126. Now this is a gate problem, gate 1999 question. Two girls have picked 10 roses, 15 sunflowers and 15 daffodils. What is the number of ways they can divide the flowers among themselves? So this is exactly similar to the problem we have done just before. I am considering first girl as H1 and second girl as H2. So I need to divide 10 roses first into this among these two girls. So I can write H1 plus H2 equal to 10, where I get the total possible cases applying the formula n plus r minus 1 c n. Here n is equal to 10, r is equal to 2, so that will give me 11 c 10 equal to 11, right? Now dividing the sunflowers, 15 sunflowers I can do as h1 plus h2 equal to 15, right? So 15 plus 2 minus 1 c 15, right? So that is equal to 16 c 15, which is equal to 16. Now the last 15 daffodils I can divide using the same principle I have done for h1 plus h2 equal to 15. So that will also be giving the answer 16. So my final answer will be 11 into 16 into 16, which is equal to 256 into 11. Okay, so that is 256, 256 here. So 6 1 8 2. So the answer will be 2816. So none of this is the correct answer. This is a GATE 2003 question. M identical balls are to be placed in n distinct bags. You are given that m is greater than or equal to kn, where k is a natural number greater than or equal to 1. In how many ways can the balls be placed in the bags if each bag must contain at least k balls? Okay, so there are n distinct bags, so I can write h1 plus etc plus hn. This is the total number of balls in n distinct bags, right? So I can think of initially as it is equal to m, right? Now they have given that m is greater than or equal to kn. That is given to indicate that even if you put k balls in each boxes, that number is greater than, sorry, m is greater than that number. That is why they have given that condition, m greater than or equal to k. Now the next condition they have given is in each bag there must be at least k balls. So I should initially place k balls in each bag. So I will lose k into n, which is equal to n k balls from the initial m balls, right? So I can formulate the new equation as x1 plus etc. up to xn must be equal to m minus nk, right? So this number is my new n. This total n boxes is my new r. So the formula n plus r minus 1 c n will change as m minus nk plus n minus 1 c. Either you can write n minus 1 or you can write m minus nk. But in the option given B, it is exactly similar to this one, m minus nk plus n minus 1 c n minus 1. So option B is the correct answer. In how many ways can B blue balls and R red balls be distributed in n distinct boxes? So I can write the equation h1 plus h2 plus etc. up to hn equal to B first. That is, when I am considering distributing B blue balls into n distinct boxes. So the formula n plus r minus 1 c r minus 1 can be applied here, but we need to note that n is equal to b here and r is equal to n, right? So that becomes n plus b minus 1 c n minus 1, right? So that is equal to n plus b minus 1 factorial divided by n plus b minus 1 minus n minus 1 factorial into n minus 1 factorial, right? So you know n minus 1 is there, minus of n minus 1 is there, so that will cancel out. So n plus b minus 1 factorial divided by, here it will be b factorial into n minus 1 factorial, right? Now this has to be multiplied with the other set of balls, which is r red balls being distributed into n distinct boxes. So the same equation will be repeated, which is h1 plus h2 plus etc. up to hn equal to r, but the only difference is b will be replaced by r. So I can apply the same formula, but b replaced by r. So n plus r minus 1 factorial divided by r factorial into n minus 1 factorial, right? So this answer is matching with option A. So that is the correct answer. The coefficient of x raised to 12 in x cube plus x raised to 4 plus x raised to 5 plus x raised to 6 plus etc. It may go up to infinity whole cube is. So this is a slight modified version of the similar kind of problems which we have done in counting. Let us first check the equation in a different way. Let us assume x cube plus x raised to 4 plus x raised to 5 plus etc. This is multiplied 3 times. That is the meaning of cube, right? So I consider x cube plus x raised to 4 plus etc. into x cube plus x raised to 4 plus x raised to 5 plus etc. Okay. Now we are asked about the coefficient of x raised to 12. So we need to know how many terms will come up with x raised to 12 as power. So suppose I take x raised to a from this set and I multiply x raised to b from this set. A and b need not be unique, it can be same number also. And I take x raised to c from the third set. So this must give me x raised to a plus b plus c, correct? And this should be equal to x raised to 12. Now I need to find out how many combinations can I get with a plus b plus c equal to 12. Now a has to be greater than or equal to 3, b has to be greater than or equal to 3 and c has to be greater than or equal to 3. So that is an additional condition. When you have that condition, we have already done such problems. We can take, keep that minimum numbers in these three boxes. So h1 plus h2 plus h3 must now be equal to 12 minus 3 given to each box, so 3 into 3. So this turns out to be 12 minus 9, which is 3, right? Now I can apply the formula n plus r minus 1 c n, where n is equal to 3, r is equal to 3. So that will be 6 minus 1, 5 c 3, which is equal to 5 into 4 by 1 into 2, which is equal to 10 is the correct answer.